Aloha! Welcome to NASA 360. I'm Jennifer Pulley.
And I'm Johnny Alonzo, and today we're on the Big Island in Hawaii. We're going to be checking out some cool testing NASA's going to be doing to get us back on the moon and onto Mars.
And we'll also see how NASA's helping scientists better understand volcanoes, those here on Earth and on other planets.
And we'll also be traveling to extreme heights to check out some of these premier observatories and telescopes in the world.
But first, let's think about going back to the moon. Some of the challenges we might have to overcome getting there. So off the top of your head, what do you think some of those challenges might be? How about building complex rockets that will get us off the Earth and to the moon and back safely? And how about some of the other developments that have to be made, such as building equipment that can stand up to the harsh environment of space, like new spacesuits, habitats, tools, etc., etc. These problems are tough enough when we just stay a few days. But what about when we start staying longer and start living in outposts for months at a time? You can imagine that the challenges can get even more complex. It actually gets much harder than you might think, because now NASA is faced with long-term problems, such as providing oxygen for breathing and building structures that will keep you safe from radiation, while also keeping the temperature equalized. Issues of generating energy and delivering fuel are also big problems that need to be solved.
Okay, so how do you tackle these problems? Well, first is we have to figure out how to break reliance from these Earth-supplied consumables, like oxygen and water. Well, how do you do that? Well, looks like we're gonna have to learn how to live off the land.
I know it sounds weird to live off the land on the moon. After all, the moon has no atmosphere and has crazy temperature swings, but we think we can do it. The plan is to use in situ resource utilization, or ISRU.
In situ is a Latin term meaning in place. The ISRU will use the moon's resources instead of bringing them from Earth. So you might be thinking to yourself, wait a minute, wouldn't it just be easier to bring what we need from Earth to the moon? Actually, there's a couple of problems with that. The first, expense. Right now, it costs about $10,000 per pound to blast something off of the Earth. And second, limited space. There's not enough room to bring everything we need for long-duration missions to the moon. So, with financial and space constraints, the best alternative? Use what's around you on the moon. So how does NASA plan to live off the land of the moon? It's one of the reasons we're here in beautiful Hawaii. NASA is currently testing some really impressive and groundbreaking equipment high above the sunny beaches on a very remote and cold part of the island.
About 75 miles east of Kona is a dormant volcano where NASA is testing equipment destined for the moon. So why Hawaii? Believe it or not, the high volcanoes of Hawaii are a perfect location to test some of the robotic vehicles NASA will be taking to the moon. The terrain, rock distribution, and soil provide a good simulation for the lunar polar region, and it helps to test the hardware and operations beyond the ability of a laboratory and rock yards. This area was also used in the Apollo era, and it was deemed the most relevant site by astronauts, meaning it was very similar to the conditions they found on the moon.
Okay, so we know that the two key consumables we can find on the moon are oxygen and water.
Right.
So how do you find oxygen and water on the moon?
Remember, there's no atmosphere, which means there's no air and there are no clouds to produce rain.
Yeah, right, but did you know you can change the composition of the lunar soil to make both?
No way.
Yes, we can. Well, Jennifer and I are going to speak to a few key people that are making that happen.
So we're here with my buddy Tom Simon. Tom, how you doing?
Good, how are you?
I'm great. All right, so talk to us about why Hawaii and what that has to do with the moon.
Well, we're here for several reasons. The main one being to be able to try out different ideas for extracting oxygen from lunar regolith. This particular location has several advantages. It has a unique characteristic that it has volcanic ash that's very similar to the regolith on the moon. We also have an excellent partnership and collaboration with the university and the Pisces organization here. And there's also cooperation with the Canadian Space Agency, and there are folks from the German Space Agency here, and there's folks visiting from the Japanese Space Agency. So we're building on our collaborations there.
Now you said the word regolith. Explain what regolith is.
Well, regolith is the very surface of the moon. Other than the large rocks, it's the dust that covers most of the moon. It's made up of metal oxides and silicates. Almost half of the moon's regolith by mass is oxygen.
How do you know the composition of the moon's regolith?
Well, the Apollo missions taught us quite a bit, as well as orbiters that we've had going over the moon in the past. We saw a lot of similarity between every location that we've analyzed and the Apollo missions went to take samples from and bring back home. Some of those samples were brought back home, and folks in the late 80s and early 90s were able to demonstrate extracting oxygen from those samples.
Here's a question for you. How can you find water and oxygen on a place that doesn't have water and oxygen like the moon?
Well, you're right. There's no easy way to get either of those. There are options that we're looking into. It's possible that there is water there. We can go ahead and find it, and then we can use it that way. It would likely be in the permanently shadowed craters. There's also the fact that the regolith being mostly made of, or having a large portion of it being oxygen,
Right.
we're going to extract it from the oxygen. The lunar descent module would have residual hydrogen in it, and we can combine that with oxygen we get from the regolith, and that's another way we can get water. And we're hoping to make enough oxygen and water such that with the life support folks, we can keep it so we never have to send a tank of oxygen and water to the moon. Help it get self-sufficient.
The hope is that these systems will be able to produce the oxygen needed to support the astronauts on the surface of the moon. Because we're still in the testing phase, NASA engineers are evaluating a couple of different design ideas, one called Roxygen and one called Pilot. Whichever design we end up using, the basic idea for how they work is this. Rovers will go out and excavate the regolith and bring it back to the processing plant. The regolith will then get dumped into the production system to begin a heating and chemical process that uses hydrogen to extract the oxygen from the regolith. The reaction produces water, which is then electrolyzed to recapture the hydrogen and release the desired product, oxygen, which is then stored for the astronauts to breathe. The hydrogen is returned to a storage tank to be reused for the next batch of regolith. The spent material will be taken away by the rovers. The whole process will only take about 3 to 4 hours to complete, with about 40 pounds of regolith being turned into between 4 and 8 pounds of oxygen. So day after day, these machines will be helping to make the moon's barren landscape livable. Another device that's being tested out here is called the Scarab. This rover is designed to help search out water on the moon. Johnny spoke with Professor David Wettergreen to find out why Scarab is being tested out here.
So Scarab was designed around the 1 meter drill. So we started with the idea that on the moon we want to take samples and measure the abundance of resources there. So we need to carry this drill around. You can build a robot with a big arm that holds a drill, takes a big arm, a large robot. Our concept with Scarab was to put the drill in the middle and make the robot able to lower itself down to the ground to get stable, put its load on that drill so you can really push it in and react all the torques.
Right.
Then stand up and drive off to the next place. We're on a steep slope here, so one of the neat things about the chassis of Scarab is that it can actually lean into the slope. So even though we're on about a 15-degree slope, Scarab's level. It's holding that drill up for the coring that they're going to do.
Listen, I saw this in Moses Lake in Washington, but it looks a little different. Can you tell me what's going on with it today?
Well, looking at it from the exterior, the main difference is the wheels.
Yes.
These are the Michelin lunar wheels. They've been developed over the last year by Michelin in Switzerland and their South Carolina office. So they're made out of a material that's going to work on the moon. It'll survive the low temperatures, it'll operate in vacuum.
Wow.
It's fiberglass material, but it's using a special type of ceramic fiber that retains its flexibility down to about 40 Kelvin. That's 230 degrees below zero.
Wow.
240 below zero.
Yeah.
And so they'll continue to flex even in that really cold temperature. So there's fiberglass around the outside and then spokes that are made of beta cloth. It's similar to the cloth that the astronauts' suits are made out of.
Sure.
And that spoke is held in tension, so the whole vehicle hangs from the top of the wheel. And when we drive around, you see the bottom flexes and it gives a nice smooth ride. So what we've been trying to do here in Hawaii is exercise an entire lunar prospecting mission. So we drive with the robot, it navigates autonomously. Scientists choose a place where they want to analyze.
Yes.
We stop, we deploy the drill, we pull up a core sample. The robot now has the entire instrument payload on board, so it crushes that sample, bakes it. It measures the amount of hydrogen, water, other volatiles in the soil, and then we can repeat that cycle over and over. So once we've shown that we can do the whole process, then we know we can go to the moon and we can find a good location for the lunar base.
Don't go anywhere, there's more to come. You're watching NASA 360.
get this. We are on the highest island mountain in the whole world. It's called Mauna Kea. And in Hawaiian, that means White Mountain.
That's right, Jennifer. And you know, this is no ordinary mountain to most Hawaiians.
It's considered to be the temple of the Supreme Being, and even today it's still considered to be a very sacred place to Native Hawaiians, some of whom still come here to worship and study the heavens. Scientists from around the world also come here to study the heavens, and this mountain hosts the world's largest astronomical observatory, with telescopes operated by astronomers from 11 different countries.
But before we head up to the summit to see those telescopes we were just talking about, our crew is acclimating here at the Onizuka Center. Now, this center was named after Ellison Onizuka. He was a former NASA astronaut.
right.
He was also a Hawaiian native.
Hawaiian native.
This center is located at about 9,300 feet above sea level and serves as a visitor information station and acclimatization stop. Why do visitors need to be acclimatized? Well, the major cause of altitude illnesses is going too high, too fast. And I actually had some first-hand experience with this. Now, given time, your body can adapt to the decrease in oxygen molecules at a specific altitude. I felt much better when I came back down a few thousand feet.
Now, we're going to stay here. About 30 minutes. Then we're going to head up another 4,400 feet to the top. It's going to be great. Our brains are going to be mush. We're going to show you what's going on up there.
Let's go. We made it to the top.
Yeah, man.
Currently, we're over 13,700 feet above sea level.
Oh, it's cold up here.
It sure is. And at this level, we are over 40% over our Earth's atmosphere, which makes it a little more difficult to talk.
Breathe.
And walk. So question, why do we have these astronomical observatories up here?
Well, for starters, the atmosphere above the mountain is extremely dry because thick clouds below the summit keep the moist maritime air down low. This ensures a pure, dry, mostly cloudless atmosphere. So, Mauna Kea's proportion of clear nights is among the highest in the world. Another thing is its location. The observatories are in the middle of the ocean, high above any city lights, so the skies are extremely dark, allowing observations of the faintest galaxies that lie at the very edge of the observable universe.
Currently, there are about 13 working telescopes here near the summit.
9 of them are for optical and infrared astronomy. 3 of them are for sub-millimeter wavelength astronomy, and 1 is for radio astronomy. These are some of the most important observatories in the world, with a combined light-gathering power about 60 times greater than that of the Hubble Space Telescope.
So, you see, we've got a lot of different telescopes doing a lot of different things up here. One of the coolest, operated by NASA, called the IRTF, which stands for Infrared Telescope Facility.
The IRTF is a 3-meter telescope that's been set up for use in infrared astronomy. An infrared telescope is important because it can see things that we can't at optical wavelengths. It can penetrate dust clouds and nebulas to provide us with information about star-forming regions and the central region of the galaxy.
Another fact about this telescope is that it's being used by astronomers around the world. And dig this, they never had to leave their home to use it.
This telescope is fitted with a variety of electronic cameras and spectrographs, and has been set up so that it can be controlled from anywhere in the world through a high-speed internet connection. Astronomers from around the world can sit in their office and control the scope with the click of a mouse, while watching images being captured right on their computer monitor, just as they would if they were on the mountaintop.
And with fewer visitors, nearby Hawaiian cultural sites and environmentally sensitive habitats are protected.
Hang on tight, there's more to come from Hawaii. You're watching NASA 360. So if you're going to be spending any amount of time on the big island of Hawaii, well, you have got to come to Volcanoes National Park. Here, you are almost guaranteed an opportunity to see an active volcano, just like this one. Why? Well, since 1983, Kilauea Volcano has been erupting every day. And with nearly 20 miles of lava flow per day, I'd say you have a pretty good chance to find out how a volcano works and see it up close and personal. In a few, we'll find out how NASA's been involved with the study of volcanoes, but first, Johnny Alonso is with Ranger Adrian Boone to find out more about these incredible forces of nature.
Hey, we're here at Hawaii Volcanoes National Park with Adrian Boone. How's it going, bro?
How's it?
Good to see you, man.
Good.
Tell me a little bit about the park. How big is this place?
The park is 333,000 acres.
So, how exactly do volcanoes work? I mean, what's going on here?
Well, what happens is in this volcano, we know there's magma just a few hundred meters below, or half a mile below, it's been said. And they actually took a helicopter over this a few months ago, about a month now, and they saw a sloshing lava lake in there, churning, bubbling lava lake.
Really?
So we know about 125 meters below was the lava lake, and currently the lava lake subsided, and so it's not really glowing as much right now. But we know there's a magma reservoir. We've known it for a while, half a mile below, and this is the first time we've seen any activity. And it started off glowing and making noises, and it still makes noises like the crashing surf tube. If it's real quiet here, you can sometimes hear it.
So you just mentioned magma. I mean, what exactly is magma?
Magma is what's below, and it's created by the heat plume and the core of the Earth having holes in the mantle, and the heat plume creating a magma reservoir, and then when it comes up to the surface, we call it lava. So magma's below, lava's at the top.
Okay. Are there any misconceptions about volcanoes?
Well, a lot of people feel that volcanoes are they're violent and explosive, whereas this volcano, we've had a few violent explosions historically, but it's been a while. 1924 is the last big one. So a common misconception is that the volcano, the whole top's gonna blow, and there's gonna be lava everywhere, and things like that. So in this volcano, Kilauea, it's a little less violent, and you can sometimes get close to the lava to see it up close and personal.
No, Adrian, thank you so much, bro. One of the big differences between a Hawaiian volcano like Kilauea or Mount St. Helens in Washington State or Pompeii's Mount Vesuvius in Italy is that they don't erupt the same way.
The magma of volcanoes, like St. Helens, is more viscous, meaning that its consistency is thicker, so the gas cannot escape as easily as it does from Kilauea, resulting in explosive eruptions. But let me give you an example. Since the start of the current Kilauea eruption back in '83, more than 1,400 million cubic meters of lava have been erupted. When Mount St. Helens erupted, it was over 10 times greater than the current Kilauea eruption because the pressure inside it was greater.
But not all volcanoes here are still erupting. There are 5 volcanoes on the Big Island, each at different stages of life. Kohala, the oldest volcano on this island, is considered extinct because the last time it erupted was about 60,000 years ago.
Mauna Kea, where all the observatories are located, is considered dormant because it last erupted 3,600 years ago. The 3 remaining volcanoes are considered active, each having erupted within the last 200 years.
So where does lava come from? The rocks moving upward in the mantle beneath Hawaii begin to melt at about 40 to 60 miles beneath the surface. The molten rock called magma rises because of its relatively low density. It then ponds into a reservoir 1 to 4 miles beneath the summit. It then follows fractures up to the crater until it reaches the surface at a vent.
So where does all the lava go here at Kilauea? Most of the lava is transported by lava tubes to the ocean, where it fragments and adds layers of rubble to the volcano. So when the lava cools, it's actually making the Big Island of Hawaii even bigger. Well over 500 acres of new land has been added to the island, making Hawaii the only U.S. state that is still growing. Of course, not all of its growth is welcome. Over 180 homes have been destroyed since the 1983 eruption began.
Now is probably a good time to talk about how NASA's involved in the study of volcanoes. I know it's a common perception that NASA mostly studies space and aeronautical problems, but in reality, NASA is working hard every day on all sorts of issues that affect our planet. So, why do we need to study volcanoes? Well, even though it's interesting work scientifically, the major reason is to protect human health.
Currently, there are more than 1,500 potentially active volcanoes that dot the Earth's landscape, of which approximately 500 are active at any given time. Although scientists keep watch over many of the Earth's volcanoes using traditional ground observation methods, satellite-based remote sensing is quickly becoming a crucial tool for understanding where, when, and why the Earth's volcanoes periodically boil over. Satellite technology now makes it possible to monitor volcanic activity in even the most isolated corners of the globe, and to routinely observe changes in the Earth's surface that may signal an impending eruption. In addition, remote sensing data offers scientists the chance to prevent catastrophic damage to life and property by determining how and where volcanic debris spreads after an eruption.
One system that's now being used is the MODIS Thermal Alert System. Now get this, it enables scientists to detect volcanic activity anywhere in the world within hours of its occurrence.
It uses data acquired by the MODIS sensors, which fly aboard NASA's Terra and Aqua satellites. These sensors see heat sources that may be active lava flows, lava domes, or lava lakes. Since MODIS achieves complete global coverage every 48 hours, this means that the system checks every square kilometer of the globe for volcanic activity once every 2 days.
This process came in handy in 2002 and then again in 2006 when a volcano in Africa erupted with little warning. Now, at the time, 500,000 people lived in its immediate vicinity, so the potential hazard to human life was extremely high.
With the MODIS data in hand, researchers were quickly able to establish the lava vent position, which enabled the modelers to predict which direction the lava was flowing and at what rate. Such information, when available in near real time, can be used to provide assistance to disaster managers anywhere that a volcano erupts, almost certainly saving lives.
Another thing that NASA's working on is keeping air traffic out of ash clouds that come from volcanoes. Now, this might not sound like such a big deal or a hard thing to do, but let me tell you something. Ash clouds can reach over 40,000 feet in the air and many, many miles wide. So it's no wonder that from 1980 through 1999, over 100 jet airliners sustained some damage flying through volcanic ash.
The problem is that jet engines operate at a temperature that melts volcanic ash, and this melted material can then cause the engine to slow and shut down. Several commercial planes have lost all 4 engines at once by flying through ash clouds with near tragic results. In one case, a 747 carrying 240 passengers flew into an ash cloud after a volcanic eruption in Indonesia. All 4 of the aircraft's engines lost thrust, and the plane descended from 36,000 feet to 12,500 feet before all 4 engines were restarted, averting a potential catastrophe.
So NASA's using satellite data to analyze ash clouds to get real-time data to pilots to help them divert from ash clouds, potentially saving lives.
Oh, and one more thing.
Yeah.
NASA's doing a lot of research on volcanoes in our solar system. Get this, thousands of volcanoes exist out there. Some are erupting ice, while others are red hot, similar to those here on Earth. Now, all of the data on Earth's volcanoes are going to help us better understand our own solar system, and of course, it's going to increase our knowledge of our own planet.
That's right. Hey, thanks for watching.
I'm Jennifer Pulley.
And I'm Johnny Alonso. See you next time on NASA 360. So how do you do that? Well, looks like we're gonna have to, sorry.
So Tom, what is left in the regulator?
No.
What is it called? And environmentally sensitive habitats are protected. Hang on tight. More, yeah.
And with fewer visitors and nearby Hawaiian cultural sites, it's not right. And with fewer visitors and and with fewer visitors. So NASA's using satellite data to analyze ash clouds to get, again, to get real-time data to get there are 5 volcanoes on the Big Island, but 2. So with fewer visitors, 2.
It's his brain at 9,000 feet.
All right, we got it.
Hi, you're watching NASA 360.
This is awesome.